Hi, everybody. This is part two of my Automate series from the Automated Conference 2025. Wanted to do this video primarily on motion control. One of the players that's right here in our area is Delta Motion. They're down in near Vancouver, down by the In-N-Out Burger. And they do motion controllers. We have one in our lab. But I wanted to show you this. Like, there's a lot of really nice, elegant motion control displays where you have independent axes that are coordinated together using constraints of motion. So, for instance, these two 3D printed helical gears are able to mesh and not contact each other on these two linear axes by controlling the linear axes and the rotary axes of this machine. So you'll notice that right now we've got the white one spinning and the blue one standing still while one linear axis moves it back and forth, and now we've got a little bit more motion going on. We've brought both linear axes into them, and then now we're talking about all four of the axes, the two linear and the rotary, going at the same time, coordinating, make sure that these gears are not actually meshing with one another. Or not actually contacting one another. The enmeshment is just all within the clearance between those teeth. So, kind of impressive, satisfying video. Like, I can just stare at this for a while. It's pretty fun. Just the coordination between all of these axes. It's done through fairly simple programming. And here's a simple motion control for essentially what is a kind of portal robot. But this company also has done this interesting little spiral motion control where it's coordinating and it's keeping the ball going down a constant spiral. So it's using just a series of linear axes to control the ball slowly rolling around in circles, spiraling down, and then it raises it back up so the ball is constantly falling. Here's a motion system. This is absolutely 100% mechanical, no control whatsoever, but I thought it was an interesting gearing mechanism using a gear. Using a gear. So we've kind of got a worm gear here, and then the other gear in the center, actually, the teeth of that gear are just bearings. And this is a hand crank mechanism. And it's just kind of fun to see. This one is another motion control one from a different company that does motion controllers. And this is coordination of the same thing, kind of mesmerizing as well, just the simple, clear enmeshment of those. All right, so here's some old school motion control. You're going to look at these, and they all have rods that are extending underneath the table of this. You look at this and you think that there's a controller in it. No, this is all cams. This is all gears and belts. This is a 100% mechanical, old school way to do automation. All those lifter arms. It's a thing of beauty, a little antiquated. So here's some motion control for simple portal robots. All right, here we get into conveyance. So all of the motion that's on these on the floor that you see there, all of the motion that's being done there between those little tripod things, that is on a conveyance system that uses magnets. All of those little pads at the bottom are magnetic levitation systems. And so they're controlling the motion of them entirely with magnets. So when like they just move apart and then it goes low, and then they bring them together and they go high. And then the robotic arm is controlling, taking the slinky up to the top of the staircase there. So it's kind of a little fun Rube Goldbergy exercise here. But that conveyance system we're going to see in multiple displays on this slide deck, because that magnetic levitation and the ability to control that is can be put to really interesting uses. It's called Planer is the company that does that. So here's another one where somebody has created this sort of video game using a projector that's projecting down on the pallets and a vision system that's sensing them, so you can essentially move those around and then the vision system will sense where they need to go. Here's a conveyance system that's taking bottle caps, lining them up and getting them ready to go. There's a lot of these sort of circular conveyance system displays all over the place. Conveyance is a big thing, and aligning parts when they're out of a conveyor is a difficult thing. And so you see it goes from being kind of random going up that way to being highly and individually dispensed on the other end of it. Here's an example of a gantry style robot that's going to be picking and placing off of shelves. And then here, this is a circuit board manufacturing thing. So it's going through and it's etching the circuit board in this step, and then it moves through this would be where it would be doing reflow, melting solder onto it. They weren't actually printing any of these. On site, they were just kind of running it through blank, going through an inspections area, and then out the other side, and basically being placed to ship. So, you know, if you have wondered how your Arduino boards get made, it's kind of a similar setup to this. Here's a vibratory conveyance system. So this is a vibratory bed that is on multiple different, so there's essentially 4 vibrators on them. They can kind of turn them on and off to direct them to go to one side or the other side of the bin here. Here's kind of your more standard conveyance system with stops, though. So the pallets can stop while the conveyor continues to run, and then as soon as the stops let go, it'll allow that pallet to continue on, which is a stacking mechanism that's fairly common to balance uneven workflows. Here's some conveyance along with lifts. Not a whole lot to explain here, apart from just you can see sometimes it's not enough to just move in a straight line. You need to move vertically as well. This one's operating fairly slowly. Get it kicked off here. But it's an interesting sort of 2-stack thing. Here's another conveyance system cubes on it, where the center is a series of pallets, and then a UR robot will take objects from the outer rink of this and place them on there. So multiple operations on here, multiple tracks. Here is the planer motor. This is their actual demonstration, where you can see this conveyance system, and it's just levitating on magnets. You can actually slide a piece of paper underneath them, moving around the product on a non-moving conveyor belt. features a rail-based system for conveyance, simulating a bottling factory. Obviously, this is pretty low scale. We have different fillers there of different juices. Another picture of a planer thing. You can see that they can spin it around. You can do all kinds of interesting light effects with the projector above. It's kind of fun stuff. This magnetic levitation, the planar conveyance thing, was in several vendors' displays. They were partnering with many people to produce interesting applications for their product. All right. Well, that's it for the motion video. We'll do one more video. The third part here is going to be on robots, and robots were everywhere. I couldn't not do robots in these other videos. The next video is going to focus primarily on the robots themselves, though. So we'll see you soon.